Assalamu alaikum warahmatullah. Today I want to share uh, IEC and IEEE for IEC standard difference for transformer design especially. From the beginning, for transformer IEC the standard is 60076, and for ANSI or IEEE it is C5712 standard. For the KVA rating, especially regarding to the power input to the transformer, is defined the KVA. But for the ANSI, this depend on the output that can delivered at the rated secondary voltage and the frequency. So IC was on input power, IEEE depend on the secondary voltage and the frequency. Then the reference temperature of the calculation of load losses and impedance. For IC 75 degrees Celsius, for liquid fuel transformer 85 degrees Celsius for IEEE. Here is the one thing: these losses especially used for not only for reference temperature, these were goes for the tender evaluation or price evaluation as well. If you want to know, let me know in comments, then I can inform you that. Then ambient temperature. The ambient temperature for IEC, ambient air temperature between negative 25 degrees Celsius and plus 45 degrees Celsius. Water temperature at the inlet not existing 25 degrees Celsius. Water for water cool design, if there is water first design. So ambient air temperature for IEEE is not exceed 45 degrees Celsius, 40 degrees Celsius, and average air temperature for a 24-hour period not exceed 30 degrees Celsius. Minimum water temperature shall not be less than 1 degree Celsius. Because it's less than 1 degree Celsius, then water doesn't flow. That's why. That is frozen. That's why they mentioned that on. And tolerance for losses, IEEE define that component losses, that means no load losses, full load losses, plus 15% subject to the communication, that are total losses. That means the no load plus full load are within plus 10%. For IEEE, no load losses plus 10% maximum, and load losses plus 6%. That is a very important thing for the impedance. That is tolerance of the impedance for two-winding transformer. The declared impedance is less than, if there will be declared impedance, and that is less than minus 10%, tolerance allowed is plus minus 10%. If the declared impedance is less than 10, then the tolerant impedance is plus minus 7.5. The above are applicable for the principal taps. For two-winding transformer within other taps, other than the principal taps, if the impedance declared less than 10%, tolerance is plus minus 15%. and so on. For multiple winding transformer, tolerance is plus minus 10% at the principal tap. So other taps or the pair of winding tolerance less than plus minus 15% to be agreed between the manufacturer and the processor. But for the IEEE, that's different. For two winding transformer, they specially inform here one thing. For if that will be less than 2.5% impedance, tolerance will be plus minus 10. But if it is greater than 2.5%, tolerance is 7.5, tolerant is plus minus 30% for three winding, zigzag winding, and auto transformer. Temperature rise, top oil temperature rise for the IEC is 60%, whereas the average winding temperature rise is 60 degrees Celsius. Hot, hot spot temperature rise is 78 degrees Celsius, whereas for IEEE, the top oil temperature rise is 65%, here is 5% more than, but the average winding temperature, uh, that is 65%. It's interesting to know that if it's goes 65 degrees Celsius, the top oil should be less than that. So it will stay on it. What is for 85 degrees Celsius? Trying to show any other day. I will continue the rest of them. Till then, thank you to be with us.